It is an extreme celestial body. In addition to being the nearest planet to the Sun, Mercury is also older, denser, and smaller than any other planet in our home system. For eons, it was nearly impossible to see this planetary anomaly up close from Earth because of the Sun's blindingly brilliant light. Moreover, nearly all research visits were impeded by the intense sun radiation. Mercury could only be thoroughly examined for an extended period of time once MESSE and GER joined its orbit in 2011. Since then, we have also learned that chemical molecules and water ice are dormant near Mercury's North Pole. Not only that, but fresh research points to the intriguing conclusion that an 18-kilometer thick layer of pure diamond is a real treasure buried deep within the globe. That's not all, though. According to another study, there are buried glaciers beneath the planet's surface, where life might have even begun from an astronomical perspective. Mercury is an outcast in the galaxy. In fact, Earth has only made 2 excursions to the solar system's innermost planet thus far. First flying by Mercury in March 1974, NASA's Mariner 10 spacecraft made 2 subsequent passes through the planet in 1974 and 1975. The unmanned spacecraft captured about half of the planetary crunch's surface in more than 4,000 photos. NASA also commissioned Mercury's surface, space environment, geochemistry, and ranging, or MESSE and GAR, the second visitor to Mercury. From 2011 until 2015, it circled the planet before finally making a deliberate crash landing on the surface. Already, preparations are underway for the third Mercury mission. The Bepi Colombo space probe, which was created as a joint venture between the European Space Agency, ESA, and the Japanese Space Agency, JWST, departed our blue home planet on October 20, 2018. Bepi Colombo is expected to give us a thorough account and fresh perspectives on Mercury's evolutionary past, according to experts. But the probe won't put into orbit around the planet until December of next year. Even though Bepi Colombo will not land on Mercury to conduct close-up observations of the planet, we have now been able to uncover some of its fundamental features. This indicates that Mercury is only 1,400 kilometers bigger than our Moon, with a small diameter of slightly less than 4,880 km. However, no other planet in the solar system can match Mercury in this area when it comes to dramatic surface temperature changes. Because at Mercury's daytime high of 430 CE, the temp falls to 170 C during the icy nights. But given that Mercury is only 58 million kilometers from the Sun, it's hardly surprising that it occasionally looks like a planetary furnace. Because of this, it completes its circle around our host star in 88 days, making it the fastest planet in the solar system. We are smarter now than when scientists first believed that Mercury had a bound rotation, meaning that it always saw the Sun the same side. In particular, throughout 2 solar orbits, Mercury rotates precisely 3 times on its own axis, a phenomenon known as fractionally bound rotation. The celestial body is categorized as an Earth-like planet because of its chemical makeup. This does not imply that it shares the same composition as Earth. Rather, it just indicates that we are dealing with a planet that has a solid surface. Regarding the composition of such solid surface, the preferred material is rough, porous dark rock that resembles the face of our Earth's moon with its furrowed craters. Speaking of the moon, there are no natural satellites of Mercury. Some researchers even believe that Mercury was previously a satellite of Venus because of its unique orbit, unique rotation, and moon-like surface form. These are the only members of our planetary system without moons, which may also be explained by this idea. Mercury's interior clearly resembles our geologically very dynamic terrestrial home, even though its exterior still resembles the dormant moon of Earth. Not to be overlooked is Mercury's almost absurdly enormous core, even if we are currently exploring its deepest secrets. With a diameter of 4,100 km, or around 84% of the planet's diameter, the planetary core is thought to be composed of 65% iron. Mercury's core alone would be bigger than the moon of Earth. Mercury became a jeweler's dream for the galaxy when the enormous iron-nickel core conveniently left room for a real treasure, the diamond treasure of Mercury. We must acknowledge that Mercury has an unusual composition in addition to a disproportionately huge core in order to comprehend the significance of this. In specifics, between 1% to 3% of carbon is found in the planet's interior, and crust is graphite. To put this in perspective, the equivalent figure for Earth is only 100 parts per million, with an albedo of 0. 6. The planet's surface reflects only 6% of incident sunlight back into space. It is also the carbon that gives Mercury's crust its dark hue. However, the graphite might have transformed into a glittering gem and existed inside the celestial body as a pure diamond. The research team headed by Yanggong Zhangzhu from the Beijing-based Center of High-Pressure Research and Technology came to this result. The specialists looked at the degree to which the planet's internal development has been impacted by the high graphite content. Mercury, like Earth, was likely once covered by a vast ocean of magma, despite the fact that the two planets are substantially different from one another today. However, graphite eventually collected on the surface and helped form Mercury's original crust, since it is typically less thick than the melt of that boiling hot ocean. However, in the same breath, the graphite also made its way into the planet's initially heterogeneous interior, entering both the core and the mantle. The researchers began their search for the glittering secret right here. They specifically addressed whether the pressure was great enough to compress the carbon into diamond or whether it stayed as graphite at the young planet's core mantle barrier. In order to determine how various compositions of Mercury's material reacted in this extreme zone, the scientists conducted high-pressure experiments and modeling. They set the maximum pressure that could be applied at this border at 7 gigapascals. The bottom line was that temperatures ranging from 17 C to 2000 C were present in addition to extreme pressure. But unlike previous investigations, the scientists included sulfur, which we now know is also abundant on the tiny planet to the early Mercury mix. Thus, the specialists created a mixture that decreases the temperature at which the silicate melt of the magma ocean starts to solidify, in addition to the carbon-containing mixture of silicates and an iron-silicon alloy for the core. Thanks to the sulfur, a little percentage of the carbon can be turned into diamonds near the lower border of the magma ocean due to the high pressure and temperatures there, which has a sulfur content of about 11%. Since the core diamonds were lighter than the remaining molten metal, they might have greatly enhanced this dazzling layer, which is just 0.1 to 200 meters thick on its own. They produced a diamond layer that may have been 15 to 18 chem thick when they were deposited at the core mantle boundary after rising to that point. But it's not quite simple to unlock the natural jewelry box that holds the prize these days. The massive gemstone deposit is unreachable, since it is concealed more than 600 kilometers below the surface of the Earth. Despite this inaccessibility, there is no denying that the experts' explanations seem incredibly fascinating. In the end, though, it's only a theoretical presumption. Is it possible to determine whether Mercury conceals a diamond layer within? The solution, however, is quite evasive. This is due to the fact that the gemstone layer is actually too thin to be recognized by indirect measurement techniques or from the outside. However, it's possible that in Mercury's early history, big impacts, volcanic activity, or circulation currents carried some diamonds to the surface. We are also accustomed to this phenomena from terrestrial diamonds, which are transported by the rising lava from volcanoes. The planetary treasure quest in the so-called high magnesium province is especially intriguing, the experts say. According to MESSA-NGER's research, the crust in this region has an exceptionally high magnesium content, which suggests that material from far below once made its way to the surface. The future, known as Bepicolombo, will have to demonstrate whether or not this also includes diamonds. As previously said, it is scheduled to examine Mercury closely as early as next year. Does life exist on Mercury? This can no longer be ruled out, though, if Alexis Rodriguez gets his way. According to the study's lead author, who detailed it in the Planetary Science Journal, there is one striking similarity between Mercury and Earth. What does that signify, though? Indeed, there are probably glaciers on Mercury as well, although they differ greatly from their namesakes on Earth. On Mercury, there are salt streams that have confined volatile substances like water, carbon dioxide, or nitrogen far below the planet's surface, but on Earth, there are still massive ice masses with a well-defined catchment region. The MESSEE-NGER data, which had detected areas with high levels of volatile elements, in turn led to the finding of the salt glaciers. Substances once outgassed and sublimated there, as evidenced by a few distinct pits and pockmarked structures. Regarding this, the researchers stress that their models provide solid evidence that the glaciers on Mercury were generated by a salt flow and that they still retain volatiles over 1 billion years after they were formed. When we go back to Earth, it will be evident why this feature becomes so crucial to the scholars. Because even the most hostile terrestrial areas, like the Atacama Desert in Chile, have habitable niches that are first only made feasible by specific salt molecules. Given this, it's possible that Mercury possesses subterranean regions that are far more conducive to life than its rocky surface. But in the end, the finding of Mercury's glaciers also holds far more importance. After all, exoplanets that resemble Mercury might have similar systems that enable subterranean life. You will also discover a button that will allow you to never miss another amazing post from us if you go underground to our video. To stay updated, please give it a thumbs up and subscribe.